Hello students, this is lesson 2, unit 4, lesson 2 practice problems. As usual, make sure that you do these by yourself and then come watch the video to find out how you fared with the answers and check your work. So on lesson 2 it says number 1, the height of water in a bathtub, which is W, is a function of time. Let P represent this function. Height is measured in inches and time is in minutes. All right? So what did they do here? Well, they said P, which is the height of the water that's in there, times 0 is equal to 0. All right, which means that what? You started at empty. And P at 4, again 4 is time, function of time. All right. Let's see. The height's in inches, time's in minutes. So after 4 minutes, it's 10 inches deep. After 10 minutes, it's 4 inches deep. And at 20 minutes, it's empty. I'm not sure what's going on here, so let's see what it says. So let's see. Starts empty. At time 0, it starts empty. I said that was A. The bathtub starts with no water. Okay. After 4 minutes, it's got 10 inches in it. Let's see. After 10 minutes, nope. The height of the water is 10 inches after 4 minutes. Yeah, that's a good way to say B. And C. After 10 minutes, the height in the water is 4 inches. All right, that looks good for the C. And then delta, after 20 minutes, the bathtub is empty. So it must be draining the water. All right. Number 2. Function C takes time as its input and gives the students a student's Monday class for output. So given a time, it tells you what class that you should be at. All right. So if you put in like the function C, you put in at 10 o'clock, it would equal English, for example. Write a statement that describes the meaning of C 11:15 equals chemistry. It says a student has chemistry at 11:15 a.m. Function F gives the distance of dog from a post in feet as a function of time. So here's your time down here in seconds. Here's how far the dog is from the post at feet. Find the value of F at 20. So this distance at 20 is right there. Boop. Right? So it looks like 3 feet. And F at 140. So you look over here at 140. Go up. And it looks like about 3.5 feet. All right? So that's how you read those. Let's see. Number 4, function C gives the cost in dollars of buying N apples. What does each expression or equation represent in the situation? Well, if I buy 5 apples, it'll cost me $4.50. That's what this means here. Okay. C at 2, it just tells me when I put the cost at 2 apples, and it equals, I don't know how they're pricing this thing. It just says 2 apples equals I don't know what in cost. So I don't know how much it cost. It's kind of blank here. There's not much. I don't have much information. It's the cost of 2 apples is essentially what it is. And so the cost of 2 apples. So you can think of it that way too, however you want to think of it. Number 5. A number of identical cups are stacked up. The number of cups in a stack is the height of the stack in centimeters are related. Well, if any of you have ever seen a stack of solo cups, you know that as you stack them on, they always have a certain amount, about a centimeter, that they go up each time. That's how much is exposed on the lip as it rises up. Can we say that the height of the stack is a function of the number of cups? Explain your reasoning. I said yes. The number of cups add the same amount of height every time. Each cup adds the same amount. Right? As long as you have the same cups each time, there should be no difference. Can we say that the number of cups in a stack is a function of the height? Yeah, you can kind of go backwards if you wanted to. I mean, you can measure the height, and then you can tell me how many cups there are, because every cup exposes the same height. We can graph it. It might not go to 0, but we can go and set out the height. It'll look something like this, We'll say when there's 0, the height is 0. when you have 1 cup, it'll be up here, and then if we go to 2, it'll be a little bit further. Alright, so it'll be a little bit steep for that first one, but then it changes tack and it'll just be boop, boop, go up the same amount each time. Right? At 0 cups, you have 0 height, but at 1 cup, you have here, add 2, you add 1 more centimeter on. I mean, that's the whole idea with space savings, of having the cups stack like that, just like chairs. Looks like that. Number 6, in a function, the number of cups in a stack is a function of height of the stack. Sketch a possible graph. It should look something like that. I mean, it could look like this, where it just jumps up all of a sudden. The height is 0 when you start out with, and then it's just a steady stack. Or it could just, depending on where you start at, where you're starting your measuring at, So something like this. As the number of cups increase, the height increases. So, all right. Okay, so identify one point in the graph and explain the meaning. At 0 cups is 0 height, right? And so with each cup, it goes up a certain amount. And then, of course, the all-important review. All right, so what we got here? Well, it's 2 equations, 2 unknowns. Right? How we solve these? Well, you got a negative and a positive here, and a positive and a negative. So you can get rid of either the x's or get rid of the y's. I don't care. I chose to get rid of the x's. So between the 3 and the 5, the least common denominator is 15. So I multiply the top by 3, the bottom by 5. I get these expressions right here, and then I add. The x's go away. I get a negative 26y and a negative 39y. Y equals 3 halves. I then take the 3 halves and I put it back into either one of the original equations, do some math, come back around, and x is 5 halves. And then I go through and I check it on the second one, and I get the same answer. On this one, between this, I got a positive 5 and a negative 8, but these are both negatives. So I chose to get rid of the y's this time, just to kind of show you a little bit different. So I multiplied the top one by a positive 3. That way I'll get a negative 6y. And I multiply the bottom by a negative 2 so that we get the positive y down here, so that the y's would go away. Right? I could have done this. I could have multiplied by the bottom by 8 and the top by 5 and got rid of the x's, but then that racks it up kind of large because you're multiplied by 8 and you get big numbers. So I chose the really small numbers this time. So what do I get? Well, I get negative 34x equals 68, x equals negative 2. Substitute back into original. I picked this bottom one because it has smaller numbers than this one with the 8 and the 24. 5 and 2 sound a little bit easier. So I put in the negative 2, and I go through and I do the math. And bippity-boppity-boo, y equals negative 4, so my solution was negative 2 comma negative 4. And I put in the other one to check it, and sure enough, it comes out, 16 plus 8 is 24. Yep, works. Okay. And that's all there is for the practice problems. Thank you for your time.